Hello everyone, my name is Amit Khan. In this video, I will discuss about the electronics measurement lab for ETCE fifth semester. How to do the lab virtually. So for that, at first we have to go to the MHRD virtual lab. Then we will go to this link www.vlab.co.in. Click here. Then we have to go to electronics and communications. After that, we have to find out the measurement lab. Here you can see it is written analog signals network and measurement lab. I have to go to this lab. Then we have to go to the list of experiments. Here we can see the list of experiments is given. We have to go to the RC, that is measurement laboratory. Today we will discuss about the lab measurement of self-inductance by Maxwell's bridge, that is experiment number 4 here. So we go into this lab to measurement of self-inductance by Maxwell bridge. Here the objective is written here and the theory part is given. The circuit diagram is also given. The theory for Maxwell bridge is given here. Then the procedure is written. We will directly go to the simulation to perform the laboratory experiment. So I go on to the simulator part. We will click here to perform the experiment. It is opened here, that measurement of self-inductance by Maxwell bridge. The procedure is written here. First procedure is apply supply voltage from with arbitrary frequency, that is 3 volt. Set the value of inductor for set inductor value tab. Choose the correct value of C1, R1, R2, R3. And switch on the supply. Then if null is achieved, then we have to simulate. So here we can see the circuit diagram is given here. So the external voltage supply arbitrary frequency is given and the supply voltage is 3 volt. It is written here. Then we have to select air port or iron. I am selecting air port. For air port, the value of L is 0.005045 and it is written here. After that, we have to choose the value of R1, R2, R3, C1 to get a null deflection. You can control this, the value of R1, R2, R3, R4 from this control section. Also we can get the data of the value of R1, R2, R3 and C1 from manual. From suppose I am giving details 1, 2, 1, 2, 3, 4. So the value of R1 becomes 1, 2, 3, 4. So at first what we have to do, we have to select the value of R1, R2, R3 and C1 for null deflection of this millivoltmeter. That means the deflection of the voltmeter should be 0. There should not be any deflection. So you have to carefully choose the values of this R1, R2, R3 and C1. So it is written here in set inductor value, choose the type of inductor from the checkbox, that is air port. We have chosen air port. And range of C1 is given 100 picofarad. And range of R1, R2, R3, RS is given. So you have to control this and choose the values of R1, R2, R3 and C1 from this control tabs or we can give the values directly here. Suppose in this condition I have chosen the value of R1, R2, R3 and C1. Four values are like this. If you keep the supply hold power supply, what will you issue? See here the deflection is 2999.8. We have to get null deflection. So for that we have to choose the values of R1, R2, R3 and C1. So at first giving the value of R1 is changing the value of R1. R1 has become now 899,842. I'm slightly decreasing this value. R1 has become 86. Choose these values by trial and error method. You have to check whether it is becoming null or not, the deflection is becoming null or not. Giving the values manually. Suppose the value of R1 is 882125. Then we have to choose the value of R2. I'm slightly changing the value of R2. I've also changed the R3 is 1 and C1 is 0.1. Let's see what we have. So the deflection is now 0.10899. That means we have achieved to the null deflection. Almost it is close to the null. So for this value we have to take the output. Then we will go to the galvanometer reading is now 0.10. That means close to 0. So there is a null deflection. So we will go to the measure inductor value. Here we can see the current voltmeter reading is 0.10. millivolt. Now we have to simulate to get the value of inductor, get the value of resistance, and to get the quality factor. Now I am clicking to simulate. The inductor value is given here 0.00011396 in Henry, and resistance in ohm, that is given 1.26. The quality factor is given 0.028. So this is the output results. Again, if you are interested, you can perform another experiment. You have to change the value of R1. Suppose I am giving the value of slightly increasing the value of R1 in the range of 102. Then let's see. I have not changed the value of R2, R3 and C1. I have just changed the value of R1. I slightly increased it. Now the deflection is 1.0941. It is also almost 0. So let's see. The result has been changed. The value of quality factor is increased, that is 0.0325. Resistance is 1.099 in ohm, and inductor value is 0.00011396 in Henry. Again, if we want to perform, I am changing the value of R1 and slightly decreasing it. Now you can see that I have changed the value of R1, and I am also decreasing the value of R2. Again, I am slightly decreasing the value of R2. You can decrease increase the value from here also. So let's see. Here the deflection have slightly increased, that is the galvanometer is showing the reading, that is 0.211. So the deflection is slightly increased. So we can take this value and now we can simulate. Then for this value the quality factor is 0.207. The resistance is 0.896 in ohm, and the value of inductor is 0.000591 in Henry. So like this we can change the values of R1, R2, R3 and C1 by trial and error method to get the closest null deflection, and then we have to simulate to get the inductor value and the quality factor. So thank you all for watching this video.